Hello, everyone, and welcome to today's call. We are just going to start just in a second. So let's wait for like 1 minute and then we can get started. Let's wait for some folks to join in. Um, okay, I think we can start. Someone can confirm whether I'm audible, I'm clear, so that we can just. Okay, thank you. So welcome to today's call. Today we are going to talk about cloud computing and understanding cloud computing in general, because later we are going to have a lot of sessions on these topics. So it is a topic which is beginner friendly. Anyone is welcome. So my name is Kevin. I'm a Microsoft MVP and a web development and Cosmos DB. And today I'm joined by a colleague who will speak in the other half of this session. And I think he is going to introduce himself during that time. So as we go on, as usual, we must um, observe our code of conduct, treat everyone with respect and kindness during this call. We are always welcoming and we use inclusive language, like we are speaking English, so that anyone who doesn't understand like Swahili can just join in and also understand what you're talking. So if someone is criticizing something, just do it in a constructive manner. and also listen with purpose and create space for others to communicate their preference. So if you have any question, you can just drop it in the chat. Or at the end of this call, we shall have a QA/QE session where you can just feel free to ask anything. So let me start from here. Money is very important. So as you can see, this is like a graph showing cloud computing and how rapidly and money continues to grow when you have bills to pay in terms of cloud computing. So you can see this is a forecast based by a company known as Ghana.com, showing how like as years go by from 2018 to 2022, you see most of companies spend dollars and dollars of money investing on cloud computing. And we shall see what that is all about. This is a lot of money which you can invest in cloud computing. So, what is cloud computing? The simplest definition is on the screen, where cloud computing is delivery of technology services. This is something like storage, database, networking, and even other things which we are going to talk about later in this call. And sorry, these things accumulate a lot of money. So some companies go on to use models like pay as you go to pay for these things. I know many of us in the call have, in one way or the other, had a chance maybe to develop something and you want to um, maybe deploy it somewhere. So that's somewhere where you're going to deploy your website so that it can be live and other people can access it. It's a cloud infrastructure. So a cloud infrastructure can contain things like compute. Compute is, as we shall see, it's where you can run a service which is now used to spin up things like an environment to store your website. Well, storage on the other side is where you can store things like images, videos, or anything which you want to be accessed by other people. We all know database is where you store your data, which is being used by your app or your organization. And the other things is like networking and software. So we shall see these things in details. So let's continue. So as I was talking, for example, like let's say Microsoft LAN, when you want to host such a website, um, you might think like, let's say it's a company like Microsoft. They have hosted lan.microsoft.com. That is just the domain, but it is a website which is running in cloud. So I think this is like the simplest example I can use for this use case. Um, okay. So sometimes you might see that when you're using a website, um, there is traffic. Traffic is where like a lot of people are trying to access a certain resource deployed online. So when there is high traffic, when there is something like low traffic, I can say it's like when few people are accessing Microsoft LAN website, and this does not cost Microsoft a lot of money for that case. But you can imagine a situation where there is a lot of people accessing Microsoft LAN and Microsoft might encounter extra costs. Of course, they can't because they are deploying it into their own services. But you can think of your website you're deploying to Microsoft LAN and it is being accessed like by 1 million people. So you'll have a high traffic, which will lead maybe to higher costs. But in turn, the infrastructure will be able to handle that traffic and your website will be still be on. So that is one of the advantages of using cloud. So hosting a website using an on-premise server, this is like you have your own servers in your homestead or in your organization. We all know what a server is. It's a computer with high computing powers like extra RAM, extra storage, which can compute and also access internet. So when you deploy your website to your on-premise server, it means that your website is running on a server which is not deployed to the cloud. It is deployed into your local premise server. So there is advantages of this and disadvantages of this. Well, we shall see both of them. Um, So this is one of them. For example, you just need to buy or rent some servers to just do this, um, which is opposed to, you know, doing the vice versa. You're deploying your website to a cloud where you don't have to buy the servers. You just need to buy the resources and the compute, which is needed to just make your application run online. So hosting a website on-premise will cost you um, a lot of money to just buy the servers and maybe take time to set up. So you need someone who is like a ground engineer or someone who is well versed in networking and uh, let's say in infra, cloud infra, where you can just set up everything, the DNS and all those networking configurations to make this happen. So that is just a cost you're going to incur. So what about hosting a website using a cloud server like Microsoft Azure? So in that situation, you will require a cloud server and a way to access the computing power instantly when needed. Okay, in this case, you can host a website on a cloud server, let's say Microsoft Azure, as I have said, and then if the traffic increases, you can instantly scale up and down. So the um, the server itself, which is on cloud, is going to scale up and down according to your traffic. So you don't have to do that manually. Most of the services on Azure can do that automatically. So hosting a website using a cloud server, you have more people to start using the website because when it scales, you don't have those downtimes to manually do that. So you're also going to reduce the amount of money you can use to set up your servers on the on-premise server. And most of these cloud providers, let's say Microsoft Azure or Google Cloud, you'll see they have models like pay-as-you-go billing. This is where if your website is using, like, let's say, a lot of the resources, you're going to pay that amount of money according to the hours these resources undertaking. And if it is using less, so you pay less bill. So in short, when we talk about cloud computing versus on-premise, on the on-premise side, we can see there is a little bit of contrast between on-premise and cloud computing. So on-premise, you have high P, less scalability, of course. Scaling on on-premise means that you have to buy more servers. You have to, let's say that is vertical scaling, and then horizontal scaling, you have to add more RAMs and those kind of things. So there's pure data security because you have to do it manually. Um, Less chance of data recovery, and then there's less flexibility, of course. And in case you need updates, you have to do them manually. There's no automatic updates. Um, and data cannot be accessed remotely because you have to set up network for that. So on the other side, on the cloud computing, which I think it's my preferred way of doing this, uh, you pay for what you use. So if you're deploying let's say HTML website or a React application, that is a static web app. You're going to deploy it in a service known as Azure Static Web App. So that service is what you need. So you're going to pay for that service to deploy your application. So you don't need to have servers or experts to do hardware, software maintenance, or disaster recovery. That thing should be covered by Microsoft if you're deploying that to Azure. So you also have automatic software updates. So Microsoft will be doing that for you. And then team, you can collaborate with other people to just uh, work on that website. Um, and also data can be accessed and shared anywhere on the internet. So other uses of cloud computing, we have already talked about store. This is like a storage where you can store images and videos. You can also use backup and recover data. Uh, Cloud native applications. These are applications which rely heavily on cloud, and you can also deploy them there. So let's say you have an application, a web app, which heavily requires maybe models, AI models to do some few things. So models are deployed in the cloud, and also your application is deployed in the cloud. So it becomes a cloud native application. It's heavily relying on that thing. So you can also stream audio and video and do data analytics and also things to do with AI. So someone might ask, why cloud computing? As I said, on premise, you have a lot of issues. You have people you have to employ to take care of a lot of things those days. A lot of things which maybe most of our users on this call might struggle to just get started with on premise. So cloud computing might be a easier way to adapt maybe whatever you are developing, and even see some results within some few minutes or seconds. So these are some of the cloud computing companies, uh, those I'm aware of. Microsoft Azure, of course, I know this is a platform where I work on during most of my projects. There's other alternatives like AWS, IBM, Zoom, Salesforce, Google, Slack, Netflix. Uh, they are companies which rely or offer cloud. So for example, Google and AWS, they offer cloud as a service and Microsoft via Microsoft Azure. So that's first ends up our first topic, like understanding what is cloud. Maybe we can jump on the power of cloud computing and see what is all about. So we have talked about what cloud offers. These are some of the services which you might come along and maybe need from the cloud. So we have talked about this compute, storage, database, so I'm not going to repeat these. And these are some of the cloud computing characteristics like virtualization, scalability. When we talk about scalability is where when you deploy your application, for example, or your database, for example, let me talk about database because an MVP for Azure Cosmos DB. So when you deploy Cosmos DB, when you provision Cosmos DB on Azure, it gives you access to access that as a service. So when you have that database and then it is connected maybe to your backend application, and this backend application has a lot of traffic towards the database. There's a lot of read and write operations to that database. So Azure Cosmos DB, it's able to scale well. When you have high traffic, it scales. So it's able to accommodate the size of your traffic. And when there's less traffic, it scales downwards towards that. So that is a concept of scalability. So there's also cost. We have talked about pay as you go. That is a cost model which you can use where you are paying the things you're using on the cloud. And then there's speed. Of course, when you're using, for example, Microsoft Azure, you see that we have data centers. For example, in Africa, we have South Africa, where is a data center in this region. So when you have South Africa as one of the data centers, and then you have some few data centers on Europe, South America, India, and I think North America, there is a lot. So your application will have speed because if you have some users who are accessing your application from, let's say, Europe side, and you have deployed a database, and then this database, it is distributed in these data centers. So those folks who are using your database um, via Europe side, they are going to access higher speeds because they'll be pinging your application to the nearest data center. And then those folks in Africa, they'll be pinging their application or the database in South Africa, which is one of the nearest data centers to where you are accessing the internet. So you'll find that your application is always on high speed because these databases or resources have been distributed all over the world via the data centers. So that is what I think speed is in this context. Also performance and reliability. So when one data center fails, the others kick on and there's that reliability and security, of course. Okay, so virtualization. This is a concept in computer science or computer engineering um, where you have a physical server which can be virtualized into various um, small servers, if you can think. For example, on the image you can see there, we are splitting a physical server into several virtual servers. So if someone is using this application um, in a traditional server, let's say an on-premise server, you'll have just one operating system and then your application. But you can virtualize this into various application and operating system in a virtualized server. Virtualized server can maximize the output of individual server and also scale, as you can see, these, 1, 2, 3, 4. And this is possible if you're using cloud computing. I've talked about scalability. I'm not going to repeat on this. I think it's well understood. Um, yeah, just think of this point. When resources are needed a lot from your server, um, the cloud environment is able to help your service to scale and accommodate that need. Talking about scaling, there is two types of scaling. There's vertical scaling and then there's horizontal scaling. If I can start with horizontal scaling, it's where you increase the number of instances. So let's say you have, I don't want to use the database, I've used it a lot, but let me just say you have a database which is running on Azure. Let's say Azure Cosmos DB. It's running on Azure. So horizontal scaling is where, let's say you have a lot of traffic going to the database. So Azure scales your database in a horizontal manner. So horizontal is this way. So that means it is going like to duplicate the database into various versions of that database. And then that is when there is high traffic. And then when there is less traffic, they all merge together into one. I don't know whether this makes sense, but that is horizontal scaling. It's like you're duplicating um, the number of instances because when your database is running on cloud, it is an instance. So when there's a lot of database um, read read and write operations, so it's able to accommodate that by instance by duplicating into various instances, and then those instances can be able to use a load balancer to accommodate all that. And then when we talk about horizontal scaling, it's not horizontal, but vertical scaling. It's where, let's say, one instance um, is kind of duplicating itself. Now it's able to increase the resources which are inside just one instance. For example, let's say the throughput it's increased. Let's say the RAM it's increased. So it's just one instance of the service, which is like um, accommodating the traffic by increasing the resources inside it. I think that can be the easiest way to say that. So cost, I have talked about cost. Pay as you go is one of the models. So you don't have to buy hardwares and softwares when you're going with the crowd. You just need to pay for what you need to use. Speed. So when you talk about speed, like when your resources are on demand, um, the crowd is ready to help you with that because um, there's global distribution of data centers and those kind of things. And also even deploying your services, it will take seconds to deploy your service into cloud. Again, performance and speed. For example, in Kenya, I think there will be a data center very soon. So when you have a data center near you, and you're accessing the cloud infrastructure in which is associated with that data center, you find that your application is more performant because this data center or the region where this data center is, it's near you. So you can imagine if you have just data centers in America for Azure, and then we are in Africa. So trying to access some resources which we have deployed in that data center in America, they will be less performant because of that. Um, you can see that tree of just trying to access something which is deployed very far via the internet. Yeah. So, and that's why there is a lot of data centers all over the world. So growth, on-demand resources, um, you know, if you want your company maybe to grow in terms of resources, and then you have a constraint which is more into computing, I think a cloud computing environment can help your company grow. And also even if it's an application, it will expand to new geographical regions because most cloud providers allows you to have a global network. So reliability. So I can simply say that um, cloud computing ensures that there is durability and availability of data and the resources because of some facts like replicating the data into multiple redundant data centers. So with these, the data center is, let's say it's impacted by something like a disaster, then the data will still remain available to other parts of that data center. I'm just walking through this fast because I've talked about them. So security, this is very crucial, by the way. So when you choose a cloud solution, um, you must think about trusting and trusting these external party to secure data. Because when you deploy something on Azure, to some extent, you're giving Microsoft that trust that, hey, I'm deploying my organization resources or my personal project resource to Azure, and I'm trusting that they are going to take care of me in this aspect. So if there are some things like risks, um, you're trusting that Azure is going to try to mitigate some of the risks associated with your resource, even things like health, how healthy your application is. Um, these are the things, if you're doing them on an on-premise server, you're going to take care of them yourself. But on this case, you're going to trust that your cloud provider is going to help you with this. So let me just iterate through cloud service models. By now you have heard me talking about on-premise and cloud. So let's try to understand a little bit about cloud computing models or cloud service models, in short. So if you think about a car, I know most of us wish, or maybe one day they wish they will buy a car if they haven't already. But think of an on-premise as you buying your own car and you have to take care of everything. And when you're using cloud on the other side, it's you renting a car to do some few things and then return it later if you don't need it. I know that example is not good because a lot of us would prefer buying a car rather than renting. Uh, but the car analogy might make sense if we just go through this. So as you can see, we have car owned, car rented, ride sharing, and public transport. So there are alternatives to owning a car depending on the level of control you want. So you can rent a car or use a ride sharing app like we have seen, or use a public transport. So when you own a car, that is the concept around on-premise. Um, so owning a car is similar to the on-premise approach. So you're responsible for everything, let's say maintaining or parking fuel, or driving or finding a route to somewhere. So those are things that you are responsible for doing. Okay. I was just checking the chat. Sorry for that. Let me continue. So when now we talk about renting a car, okay? So this is something we call infrastructure as a service. So remember, these are the things we are talking about. If I can just remind you, we are talking about uh, cloud service models. So one of them is on-premise. So let's go back there. So on-premise is that I have talked about on-premise. Let me just go to infrastructure as a service. So infrastructure as a service, it's a situation where now you're in cloud, you're not on-premise, but model is infrastructure. So as a service or infrastructure as a service is similar to renting a car. So the car vendor supplies the infrastructure, like the car, where you are responsible for driving and fueling. So this is what happens with infrastructure as a service. So you are responsible partially to doing whatever car is needed so that you can enjoy riding it. But to some extent, the owner is also responsible. Good. So let's talk about platform as a service. So platform as a service is also another cloud concept, uh, where now your running costs are also outsourced. So you still control the route you take, but these other things, they are controlled by um, whoever is riding the vehicle. So you are not responsible for that. So let's say you're in a car which your friend rented that car. So you're just there uh, riding alongside him. So you're not responsible for driving the car or fueling or even renting the car. You're just responsible to know which route you guys are going or something like that. So that is ride sharing. So a good example of a platform as a service is um, Outlook or Gmail. So these are two services I know most of you are using. So Outlook or Gmail, are they platform as a service? No, sorry. Those are software as a service, if I'm not wrong. So platform as a service, I'm trying to think of an app which, but anyway, I know I have some examples. Um, but anyway, let me not
App
confuse you.
service. App service. in Azure?
Yeah, yeah, I know app service in Azure, but I'm trying to use an example which people can know who have never used Azure. But anyway, we shall try to see good examples to differentiate. But a simple example of infrastructure as a service is where you need a virtual machine of Windows operating system. So you go to Azure and then you provision a virtual machine, and then that virtual machine, you can use it as your computer via your computer which you have locally there. So in such an example, that is an infrastructure as a service, because in that virtual machine, you can set up other things like your coding tools, like, I don't know, an email server inside that virtual machine, um, a mailing server, those kind of things. And then platform as a service, if anyone has ever coded in this call, it's where you have a tool which can help you to deploy your application. So I don't know whether you guys are aware of Azure App Service or Azure Static Web App. Azure App Service is a service which you can use to deploy any backend application, be it a .NET application, be it uh, a Node.js application, be it a Python application, that is, or a PHP application. So Azure App Service is an example of platform as a service. Or Azure Static Web App is also another example of a platform as a service. It's a platform you're using to deploy something on top of it. Okay. So on Azure Static Web App, you're not responsible for anything except provisioning, saying that this is the route I want, this is the resource I want to, to buy so that I can use it. And then by using it is just adding your resources to run on top of it. If that makes sense, that is a platform as a service. Cool. So when we talk about software as a service, it's a software that you just provision and enter your credentials and use everything inside it. Okay. Like a public transport. So you just go inside a matatu, pay the fare, and then you just sit. You don't care about other things. You just know that when you reach to a certain stage, not stage, bar stop, bus stop, you'll just be into your destination, and then you go to wherever you want. So an example of software as a service is something like Outlook, Gmail, um, LinkedIn, or any social media application, let's say um, Instagram, Facebook, I
Teams.
think Teams, Microsoft Teams, which we are using for this call. These are softwares as a service. We just uh, purchase a license and then enter your credentials, start using the software. Nothing else you're going to do with that. So I think that's enough trying to explain both of them. So this is just like the vertical way of doing it, advantages and disadvantages. I'm just going to go through this very fast to the end. So as we have talked about infrastructure as a service, you can see these are things like Google Compute Engine, Microsoft Azure, Amazon Web Services, and other things. Like there's a lot here, but it's more of an infrastructure which you're going to rent. Platform as a service, these are web apps like Azure Static Web Apps, or also things like Azure Log, no, low code, no code platforms like uh, Power Platform. These are platform as a service. Um, Software as a service. These are like the normal apps we use. And you can see platform as a service is mostly inclined to developers, and infrastructure as a service. These are things which someone have to configure to add. Someone who is skilled enough have to add some tweaks to us these services so that they can meet the needs of the users. And then software as a service, this is a software which is already there, and then the end user is just going to consume it. So if you can put this into an Egyptian pyramid, you can think of them as infrastructure as a service as down there. So uh, the user has a lot of control over it. Platform as a service is like in the middle. Software as a service, the user has no control over it. But um, in terms of abstraction, abstraction is hiding some elements of something so that you can't see the inner working of it. So when you're using something like Outlook, you don't know anything about Outlook, which programming language they're using to build it or anything. Sorry. So what you just know is that they have hidden everything from you. You can only add your email and your password to access the emails which other people have sent to you. So there's a lot of abstraction into software as a service, followed by platform as a service. But in terms of infrastructure as a service, there's less abstraction. So I know the word, if you have ever done anything to do with object-oriented programming, so you know what abstraction is, but control is just normal knowledge. So I know already taken most an hour, but let me wide up. So by the way, there are other types of crowd service models. For example, function as a service. So who can tell me an example of function as a service on Azure? Function as a service? I know there are crowd gurus, or if, even in AWS, if you like. Yes, Rehan.
Yeah, I had interacted with Azure Functions, I think.
Yes, yes. Azure Functions is one of it, it's I think it's the only uh function as a service. Not I think it's the only if I'm not wrong. So this is where you're just writing bunch of functions which will be executed in a I can say serverless environment if that's okay with you guys hearing the word serverless by now. Yeah. So it's something which can only be invoked or it's something which can only run when it is triggered by something else. So these functions will only run when they are triggered by an action. So in this kind of in this type of architecture, it is known as serverless. So there's also serverless billing models which are associated with this. For example, I think also Vercel, they have this edge architecture um, where you can deploy Next.js and other React-based applications. So they use this serverless billing model where you are not charged in terms of how the application is running like a normal server, but in terms of computing and other crazy things which are associated with serverless. I can see also John Mukwana is talking about AWS Lambda. Yep, that's another example of a serverless architecture or environment in Amazon. Yep. So as I wind up, these are other um, types of service models. So you can even talk about hardware as a service, database as a service. These days, even we have AI as a service. For example, if you go to uh, OpenAI and then you purchase the ChatGPT access, that is AI as a service because the only thing they are giving you is an interface where you can just chat something and then you get some prompts back. But in the real sense, you're just um, buying AI as a service. And that's all I had for you guys for today's call. So I'm just going to call the next speaker to take over for some few minutes.
Okay, thank you, Kevin. Yeah, I'm the next speaker. Okay, so let me share my screen. Okay, I think you can see my screen, right?
Yes, we can.
Okay, thank you so much, Kevin. So my name is Rehan Liai, and I'm a Better Microsoft Learn Student Ambassador. Yeah, and it's fun talking about cloud because it's the next big thing. There are major roles coming up. We have a data center coming up in Kenya. Yeah, so it's good to learn about the cloud. So I'll be taking you through the cloud deployment models. Then we look at regulations on the cloud, which is very important. Then we jump into the fun part, cloud rules, where we get paid to do some jobs in the cloud. Okay. And if I get unmuted for some reason, please tell me. So or notify me. Okay. So let's look at cloud deployment models. Okay. So we can split cloud computing into two, where Kevin talked about the service models. I think he explained them really well. And then I'm going to look at deployment models, which is the public cloud, private, and then hybrid. Okay. So choosing a cloud deployment model is one of the most important choices to make when migrating to the cloud. It's informed by how much control you need over the cloud environment, which is defined by your business requirements and budget. Okay. And there are several models, but the most common are the public, private, and hybrid. So let's go through each of them and understand their unique values. So the first one is the private cloud model. It's private by design and is designated for exclusive use by its tenants. This means to access a private cloud, you need a connect or you need to connect to a network link, which means special network access needs to be set up by your IT. An organization may hire a third party to host their private cloud infrastructure or host it themselves. The private cloud model can be appealing because infrastructure is designed for exclusive use in the private cloud. So this gives an organization direct control over the resources available alongside with how data is stored. For example, you can specify what kind of operating system and the exact hardware you want. And this flexibility is a flexibility that does not come with other models. This is especially useful if there are like specific security requirements or risk, but it's usually requires more investment in terms of time and capital expenditure compared to other models. Consider the infrastructure that needs to be designed, hardware that needs to be bought and set up and maintained. However, this decreases if third party like IBM, Rackspace, and let's say they provide and maintain the hardware. You may be wondering how this is different from on premises. Okay, so if so, good. That's a good question. The infrastructure in this model adheres to cloud principles, meaning it uses virtualization that allows on-demand compute resources. Okay, so private cloud can be located off premises also. Okay, so the second model is the public cloud. Uh, the cloud infrastructure is shared and open for use by the general public. The infrastructure is owned and managed by a cloud provider like Azure, which will be looking at all over these sessions. And public clouds are internet accessible. Okay. And this lets organizations get started quickly with minimal investment. They don't have to host or commit to an infrastructure. Instead, they can pick up what services they need from a provider. They can also instantly buy more capacity, making it easier to scale. And if it's important to have direct access to data centers or hardware than public cloud, Okay, then public cloud is not a good choice, right? Yeah. So public cloud providers keep their data center location secrets even to their clients for security reasons. So let's see the third model, which is the hybrid. This is when an organization uses a combination of two or more distinct models. The different models interact with each other via a network link and can share data and services. It's more of a question of where data and services are physically stored. Okay, for example, you could store a sensitive patient data on a private cloud for security reasons and use an application on the public cloud, like a business intelligent tool to process it. Hybrid clouds are useful in the case of cloud bursting. This is when a private cloud is overwhelmed by demand and hits capacity. So to avoid disruption of services to the users, we could like move that traffic to a public cloud instance. So a classic example of this is the seasonal spikes. For example, retail businesses can expect extraordinary traffic during sales periods like Black Friday or Boxing Day, and this allows organization to cost efficiently handle periodic spikes with per use pricing. I hope we are together. And so there are other cloud deployment models to consider, including multi-cloud. So multi-cloud combines different cloud provider services. For example, an organization could use Azure for backups, maybe go to AWS for web hosting, and Google Cloud for analytics. Multi-cloud provides the flexibility of choosing pricing plans and service offerings. Let's say it it also reduces reliance on one vendor. Don't confuse this with hybrid model, which uses a combination of cloud deployment model and not services. Okay. And another model to consider is the community model. This is when the cloud's infrastructure is shared by a specific community for the exclusive use. Usually, this community has a shared interest or concern, whether it's having the same security requirements or jurisdiction, or maybe they are sharing a mission. Let's say this shared infrastructure allows for easier collaboration and sharing of data, where it's research data between institution or government data across agencies. The infrastructure itself can be managed and hosted internally or externally. Okay. So let's look at the next part. The second part of the presentation is the regulations on the cloud. Now let's talk about the way local regulations and laws can affect an organization's cloud infrastructure. Let's begin by an example. So imagine a fictional social media company founded and based in the US. They started with a data center in the US, but as they grow their user base to international audience, they add a data center in Europe and another one in South America, and eventually another one in Africa and another one in Asia. So having servers spread out across the globe reduces latency, right? So the greater the distance between 2 points, the longer it takes for data to get there. We can say that this delay between the moment data is transmitted and the moment that it is received is known as latency. Having servers spread out across global the globe, can say that it reduces latency, as you can like the space between them. So this means when someone wants to access the account in Australia, the request will be sent to the nearest server, and rather than a server in the US or South America, let's say these Australian users just signed up for an account at this fictional social media company. That means our personal data was just sent outside the borders of Australia. And let's say it's something tricky here. Okay. So Australia has regulations on how data should be processed and stored. There will be regulation on data, whether their data center is in Asia And an example of data privacy law in the Europe, or let's say the European Union's General Data Privacy Regulation, it's also called the GDPR. And that's a good example of the type of regulation I'm talking about because it regulates how personal data is collected and processed and stored from users in the European Union. Okay. So, for example, before a company collects any data that they need to explicitly get consent, companies also need to notify their users of any data breaches in a timely concern or a timely manner. A personally identifiable information must be encrypted, anonymized, and pseudonymized when stored depending on the scenario, and some regulations affect how data can be moved physically. So, for example, personal data can't leave the EU borders unless the company can guarantee that the data will have the same level of protection wherever it may land outside the EU. So, can you see how this affects cloud computing, where data can move to different servers around the world, and there is a major incentive to comply to the GDPR. So, and the fine can be up to 20 million euros or 4% of the company's worldwide annual revenue, whichever is greater. And a lot of this regulation talk about personal data. And what does that exactly mean? The European Commission defines it as any information that relates to an identifier, what was it called? It was identified or identifiable living individual. Yeah, okay. So different pieces of information which collected together can lead to the identification of a particular person. And this can also constitute of their personal data. So this includes the home address, the first name, blah, 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 email, location, and IP, okay? And even racial or ethnic origin, political opinions, sexual orientation, and health-related data. Some of these on their own may not identify a specific individual. But for example, if you combine all the information or maybe the location data of a given person, it can get much easier to identify who they are by where they spend the most of their time, like their home address. And let's say personal data is often referred to as PII, which stands for personal identifiable information. And GDRP is the most known data protection regulation because it's massive of its massive impact. And several countries followed this suit to comply with aspects of the GDRP, and so that data could be more easy, can like flow easily between borders. There are a couple of other data protection laws, new and old, from other parts of the world, including Brazil, the United States, Japan, Thailand, and Canada. So we can't go through each regulation in detail, but the point here is it's crucial to check the local regulation. Protocols may be different in like different countries. To let's say they can influence where the companies choose to set up their data in Kenya. In Kenya, in their data centers. So example in Kenya, so they have to comply or share how the data will be stored and is it safe for users in Kenya, okay? So let's look at cloud roll-off. That was regulation. I think it's just a bit of history and something you should know about cloud computing. So let's look at cloud roles. The employment search engine indeed listed cloud computing as the most in-demand skill in February 2020. And LinkedIn has listed it as the second hard skill companies need mostly after blockchain. What does this mean? This means cloud computing skills are ranked as more in demand than artificial intelligence and machine learning. Okay. So in fact, all the major cloud providers have established certifications for different cloud skills and roles, and specific to their cloud platform services. So these are viewed as very valuable in today's job market. Okay. So familiar data roles like data scientist, machine learning, uh, data engineers, and data analysts can all be beneficial from learning about in the cloud. So, for example, data scientists can benefit from running computationally expensive analysis on the cloud, which not only saves costs but also reduces the time it takes to run because of the computation power available in the cloud. Okay, so machine learning scientists can train and deploy machine learning models on the cloud. So this is something that's typically computationally expensive, especially when we are talking about deep learning. It's standard now for data engineers to be proficient on that in the cloud. And so data engineers build pipelines on the cloud to ingest, transform, and store big data securely and efficiently. And even less technical roles, such as data analysts, can be expected to know how to access data from the cloud via business intelligence tools like W and Power BI. And so generally having analysis in the cloud makes it easier for teams to collaborate because you aren't passing files from one machine to the next. Okay. So additionally, the rise of cloud computing has also created new job titles, notably cloud architect and cloud engineer. Yeah, so it has also increased the needs for roles like DevOps. That's the developers and IT operations team coming together, and also the security engineers. So let's go through briefly to understand how they work to make the cloud possible in an organization. So as you can see, there is often overlap in how these growing roles are defined. So a cloud architect, this lady here, is a solution architect essentially for the cloud. A cloud architect takes the technical requirements of a business problems, design an appropriate cloud infrastructure, and comes up with a plan to deploy the said infrastructure. And they have to ensure that their design is scalable and optimized for cost. Okay. And another one is the cloud engineers. So they build and maintain and monitor cloud services. They are often responsible for migrating on-premises solutions to the cloud. And this title is often used as a catch-all for any technical work required on the cloud. So for example, in smaller companies, the cloud architect and cloud engineer can be one role. Okay. So let's look at the DevOps engineer. So DevOps combines software development and IT operations. Previously, there were system engineers who maintained server infrastructure by physically configuring hardware. As Kevin said, that was infrastructure on premises. Okay. Now we don't we do that by code, which is the developer aspect of DevOps. So DevOps engineer ensure the reliability, availability, and scalability of the cloud through software development and automation. For example, if there is a rise in usage, there should be some automation to increase resources, or if a server shuts down unexpectedly, there should be an automatic patch and redeploy. Okay. Yeah, we shall look at that over the next session. So as we discussed, security is very important on the cloud and requires different technical requirements depending on their geographical area. So security engineers specify the technical security requirements of an organization's cloud infrastructure. They work to test and assess the security of data on the cloud. So generally, they are responsible for protecting the organization and using that data for technical perspective. And so I think that was it. We have looked at the cloud deployment models, regulations of different countries on the cloud, like they which use cloud. Then we have looked at cloud roles which you can pursue. By the way, you're offering these courses for free. So every Saturday, just jump in. You never knew you could land a job in any of these roles. Okay. So that was the presentation. Thank you for listening. I'll hand it over to Kevin. Okay. Thank you.
Okay, thank you so much, Rehan, for that. As Rehan has said, I want to share something, Rehan. Maybe you can stop sharing so that I can share. Yeah, so next week, a time like now, we'll have another call on this. In short, we'll be having a call like this every weekend on a Saturday at 7 p.m. So all the way to 8. So next week, just in case you want to know what we'll be talking about, I'm just going to show you a little bit of that. And then, Kemboy, for the time being, maybe you can share the form on our chat. So this form is